Imagine the smallest piece of matter that you can think of. You might have thought of a proton. Add one electron in orbit, and we have the simplest atom, hydrogen. This video is an overview of Topic 2, Atomic Structure. In this video, we have three subtopics: the atom, the mass spectrometer, and electron arrangement. As you probably already know, there are three parts that make up all atoms: protons, neutrons, and electrons. The protons have a positive charge, while the electrons have a negative charge. We can describe any atom that we can make with these three things using just two numbers. A is the mass number. It is equal to the number of protons and neutrons together, while Z is the atomic number. It is equal to just the number of protons. On the periodic table, all elements have a name and a symbol. This atom pictured here in the background with two protons, two neutrons, and two electrons is the element helium. This is one of the earliest mass spectrometers. We'll learn more about exactly what they do and what they're used for in a later video. For now, we'll just learn that they work in 5 stages: vaporization, ionization, acceleration, deflection, and detection. Electrons in the atom are arranged about the nucleus in concentric circles known as electron shells or energy levels. The first electron shell can fit 2 electrons. This corresponds to hydrogen and helium. The next energy level can accommodate 8 electrons, and this corresponds to the elements lithium through neon. The third electron shell can accommodate 8 again also, and we can see this is why the periodic table is laid out the way it is. Every row of the periodic table corresponds to another energy level being filled in with electrons. Can you figure out how many electrons can fit in the 4th energy level? Electron energy levels, or shells, are not really evenly spaced like this, though it makes a nice picture. In reality, they're laid out much more like this, where there's very large gaps between the first few energy levels and increasingly smaller gaps as we go outwards to the outer energy levels. The spacing of the electron energy levels leads to characteristic colors for every atom. But first, we need to talk about light and energy. Light is a wave, and waves come in different shapes. This first wave has a short wavelength and a high frequency. The second wave has a long wavelength and a low frequency. The shorter wavelength, high frequency wave has a higher energy, while the low wavelength, low frequency wave has a low energy. The higher energy side of the visible spectrum is the purple end, whereas the low energy side of the visible spectrum is the red end. Now back to the spacing of the electron energy levels. If we imagine an electron falling down from an outer level down to the lowest level, they have a long way to go. If electrons were to fall down to the second energy level, they would have shorter distances to go. So what does that mean for color? If an electron really does fall down from a high energy level to a low energy level, it's going to be losing energy, and it gives off that energy as electromagnetic radiation, some of which is visible light. If it falls down a medium distance, it will give off a longer wavelength, lower frequency color of light. If it falls a shorter distance, the light it gives off will be even longer wavelength and lower frequency. This leads to a unique light fingerprint for every element. We call these light fingerprints emission spectra because they are the spectrums created when electrons falling from high orbits to low orbits are emitting light. Thank you. That's it.